Hey everyone, this is Bhargav Suthar, and today we are going to learn propositional logic. Now see, in this today's session, we will discuss examples based on logical connectives that we did earlier. Now let us discuss some of the examples. Now first, express the following statements in propositional form. Now we all know that what is a propositional form. Okay, so the first statement is there are many clouds in the sky, but it did not rain. So first, what we will do, we'll divide this statement into parts. So let P equals to there are many clouds in the sky. See, the whole statement is there are many clouds in the sky, but it did not rain. So the first part is there are many clouds in the sky, and the second part, it rained. See, the given statement is it did not rain, but we will convert it whenever there is a negation part, we will convert it into the positive form. So Q is it rained. Now we will combine it. So see, there are many clouds in the sky, but we know that but stands for and. So what will be the proposition form? So it will be there are many clouds in the sky, and that is P, and but means and this, not Q, because we have taken Q as it rained, but not Q, that is it did not rain. So P and not Q. Let us discuss the second one. I will get first class if and only if I study well and score above 80 in mathematics. So we will divide this statement into parts. So what will be the first statement? It will be let P equals to I will get first class. Then second, I will study well or I study well. Then third, I score or simply I score above 80 in mathematics. So there will be total 3 parts. Okay. Now I will get first class if and only if. So that is a proposition. Then if and only if I study well and is also a proposition. So what will be the propositional form? It will be like this. Hence, see, I will get first class, that is P. Now if and only if, and that stands for the symbol, this double implication, and I'll study well and score above 80 in mathematics. So that means there is a bracket. So Q and R. So again, I will get first class if and only if, that is double implication. I will study well and score above 80 in mathematics. So this will be the proposition. So let us take next example. Computers are cheap, but softwares are costly. So again, we will divide it into parts. So the first statement will be computers are cheap, and second will be software are costly. This is easy one, but stands for and. So it's simply this, hence P and Q. So computers are cheap, but softwares are costly. Now it is very hot and humid, or Ramesh is having heart problem. So let us divide it into how many parts? I think there will be 3 or 2. So let P equals to it is very hot, then Q, it is humid, and third one, Ramesh is having heart problem. So it is very hot and humid, or. So and or, it is a proposition. So what will be the propositional form? It is very hot. So that means P. Then it is humid. So and Q. So it is humid and Q. Or Ramesh is having heart problem. So R. So that means or R. So P and Q bracket or R. So this will be the propositional form. Now if I finish my submission before 5 in the evening and it is not very hot, then I will go and play cricket. So how many parts will be there? So let us divide it into how many parts? First, if I finish my submission before 5 in the evening, so that is the first statement, and so that is a proposition. It is not very hot. See, again, it is the negation form, so we'll convert it into the positive manner. So it is not very hot. So just simply Q equals to it is very hot. Okay. Then that is also a proposition. I will go. So the third part is I will go. So this is the third statement, and is also a proposition. And fourth statement, I will play cricket. So we will just combine all these statements and put into propositional form. So what will be it? So it will be like this. So hence P. So I finish my submission before 5 in the evening. Then end. So end means and it is not very hot, but we have taken Q as it is very hot. so P and not Q, and then if and then, that is implication, so implies this R and Q. So R and Q, so R is I will go and I will play cricket. So this is the propositional form. So second example, see, if P stands for it is cold and Q stands for it is raining, then translate the following into symbols. So we have given here the statements and we will translate it. So it is cold or it is raining. See, it is cold means P and it is raining means Q, and we have here in the specific example there is or in between. And what is or? And that is the V symbol. So the proposition will be like this P or Q, that means the symbolic form. It is cold or it is raining. Second example, it is cold but it is not raining. So it is cold, that means P, but stands for and it is not raining. But if we have taken Q, it is raining, but here in example it is not raining. So that means it will be P and not Q. Simple. Then third, if it is not cold, then it is not raining. So if it is not cold, so that means not P, then it is not raining, that means not Q, and then if and then, that is also a proposition, so it will be not P implies not Q. Easy. Then next, sufficient condition for rain is that it is cold. Now see, we have studied this type of statement, sufficient condition, necessary condition, and it is very easy. I think it is P implies Q or Q implies P. Just think about it. So it will be Q implies P. Then next, a necessary condition for raining is that it be cold. So it will be P implies Q. It is easy. And last, a necessary and a sufficient condition for raining is that it be cold. So it will be this P double implication Q. Third example, express the contrapositive, the converse, inverse, negation form of the conditional statement. The statement is given if X is real, then X is rational. So what we'll do, we'll just convert this into the symbolic form. So again, if X is real, then X is rational. So the P will be X is real and Q will be X is rational. Okay. Now what will be the symbolic form? Here the proposition is used if and then. So if then, it is the proposition. So in symbolic form, it will be this P implies Q. So P implies Q, that means if X is real, then X is rational. Now we will convert, or we will find contrapositive, converse, inverse, negation form of the P implies Q. So first one, the contrapositive statement. Now we know that if P implies Q, then what will be the contrapositive of this P implies Q? And it is easy. It will be not Q implies not P. But see, the question is if X is real, then X is rational. That means it is in statement form. So obviously we will have to write it into statement form. So not Q implies not P. So what does that mean? So that is X is real, X is rational, and here we have not Q. So that means the statement will be if X is not rational, then X is not real. So now second, the converse form. Now if P implies Q, then what will be the converse form? It will be Q implies P. Now what is Q implies P? Into the statement form, we have P as X is real and Q is as rational. X is rational. So Q implies P. So if X is rational, then X is real. Easy. So if X is rational, then X is real. So the third one, what is the inverse of whatever the question? So the inverse, if P implies Q, then the inverse will be not P implies not Q. Okay. Now not P implies not Q. If X is real, then X is rational. Now what will be the not P and not Q? So not P, that means if X is not real, then X is not rational. Then negation form. If P implies Q, see this one is important. We have given the statement P implies Q. So that means negation of P implies Q. That is negation of P implies Q. Now we have used one property that we will discuss in later sessions. So P implies Q, that is equivalent to not P or Q. So negation of negation P or Q. Now whenever negation is in the bracket, so you will get not of not P, you will get P, and negation of or, that is and and negation of q, that is negation q. So that means this equivalent to p and not q. Okay, so what will the statement form? X is real and X is not rational. Let us discuss next example. Construct. So this type of example can be also asked. So construct the truth table for the form. This not P or Q implies Q. See, we need to just construct the truth table. So how many statements are there? First, there are only two statements, that is P and Q. Okay, so in truth table, how many columns will be there? First column will be this P. Okay, then Q. Now not P is also there, so the third column will be not Q and not P. Then Q we have already done. Now not P or Q. So that means fourth column will be not P or Q, and last this whole statement, that means not P or Q and Q. Okay. Now see, there are as two statements, so there will be four possibilities. Either both are true, both are false, one is true, another one is false, and one is false, then another one is true. So this PQ will be TT, TF, FT and FF. Now see, not of P, that means TTFF is there, so not P will be FFTT. Okay, now not P or Q, so that means the second and third column. Okay, and what is how to calculate or? Whenever there is T, only one T, so it will be T. So that means this TF, so you will get T. FF, both are true, then it is false. Both are false, then it is false. Both are true, then it will be true. And last, anyone is true, that will be true. And last column, TT means T, then FF, that means true, then FF. See, TT means T, then FF means true, then both are T, then true, and FT means F, because the conclusion part is F. Okay. So next example, construct the truth table for the form this not P implies R and not P double implication double implies Q. So for the construction of truth table, how many columns will be there? So first the solution. So first this P, see there are, I think there are total 3 statements. So you will get P, Q and R. Now see, not P is there, so not P, then not P implies R, then you will get not P implies R, then this P double implication Q, so P double implication Q, and last this whole statement, so this whole statement. Okay, so see, we have total how many? 3 statements, so there will be total 8 possibilities. In all the previous examples there were only 2 statements, so we had 4 possibilities. Okay, so now here we will have 8 possibilities. So how to just remember? See, there will be 8 possibilities. So see, first this fix TT. Okay, so we will have 2 possibilities, either it is true or it is false. Okay, so 2 are done. Now then fix this T and F. So we will have 2 possibilities, either it is true or it is false. So TFT and TFF. Then again this fix F and T. Okay, so we will have T and F, and last fix FF. So fix FF, so we will have either T and F. So this is how you can create this possibilities. Now see, T. So what will be not P? So T 4 times T and 4 times F. So not P will be FFF, F and 4 times T. Then not P implies R. So that means not P implies R. So it will be TT, TF. How? See, not P implies R. So this 4th column and R. So F. So we need to just consider the conclusion part. So FT, so that means T. Then FF, both are false, then it is true. Then FT, so just T. The conclusion part is T. Then FF, so both are false and then it will be true. Both are true, then also it will be true. Now TF, but the conclusion part is F, so it is F. Then both are true, then it is true. Then TF, so it is F, so here it will be F. Now P double implication Q. So how to write P double implication? That means is consider this first 2 columns. Okay, so whenever both are true, so it is true. Both are true, so it is true. Anyone is false, so it will be false up to this. Now both are false, then also it is true, and both are false, then also it is true. So that means both are true, then it is true, and both are false, then it is true. So in short, if both are same, then it is true. Okay, and the last column, this fifth and sixth, and in between there is end. So how to calculate it? So TT, so T, TT, so T. Now TF, anyone is false, so then false. So TF, then false, then DF, false, FF, then F, double T, so T, and anyone is false, so it is false. So this is how you can construct a truth table. Thank you.